All right, this is one of the big cracks right here.
Welcome to part 4 of this series. In this part, we take a trip to Yota1 Performance in Riverbank, California to have both of Sean's heads vacuum tested, pressure tested, and resurfaced if they pass both those tests. At the end of part 3, when I saw that crack between the valves, I thought that was a slam dunk, that was the culprit of the misfire he was having in the number 3 cylinder, but that's not necessarily the case. You can have a detonation crack, but if it hasn't reached the coolant jacket yet, allowing coolant to invade the cylinder, then it still is technically a good cylinder and it won't cause you any problems. When we visit Yota1 Performance, we're going to be working with their most experienced machinist and engine builder, this guy Alan. He has 45 years of experience in that industry, and you're going to learn a lot. We're going to show the teardown of a head. We're going to show how it's vacuum tested. We're going to show how it's pressure tested. We're going to show how they build up the head. And then finally, we're going to show you how they resurface it on their fancy machine. So sit back and relax and enjoy part 4 of this series. All right, we're in the machine shop. We have Al, he's the expert here that we're going to be working with today. The first process we're going to do is we're going to get the heads clean because they want the heads clean before they pressure test them in their pressure tester. So here we go.
This is called a jet spray cabinet. It uses a mild caustic solution, heated up to about 180 degrees. And that will clean most of the oil and grease and a lot of the carbon off. We use this a lot.
It's like a washing machine for your parts.
That's exactly what it is. Set that in there.
How long does that run for usually?
15 or 20 minutes, and that's about as much good as it'll do. You take it out, pressure wash it, and if you want it cleaner, you put it back in for another 15 or 20 minutes, and it'll clean it a little bit better.
We've got the heads in the jet wash, and while we're waiting for them to be cleaned, we have Al now analyzing the head gaskets that came off the engine. He's going to describe a few things and how you could look at them for imperfections.
On a multi-layer steel head gasket, you have one piece steel there, and there's several layers with sealer in between them. What makes these hard to read is this is all one piece. They have an embossed raised spot here for sealing. On a composite gasket, they have a fire ring that is crimped onto the composite, and when those blow, you can actually read what's going on in there. It will show you, it'll burn the fire ring and leave marks. And on your multi-layer steel, they tend to not do that. So it's not showing me very much here.
But if it was showing something, what would you see?
You would see a scorched mark on it.
And you're not seeing any of that?
I'm not seeing it, no. But when we get the heads back in after cleaning, we can look there for scorch marks. I will see more on the head than I will in the gasket.
If there was a composite gasket, you could see a more telltale sign of a failure rather than these steel type of gaskets, right?
Right.
Okay.
The other part of that is the multi-layer steel gasket is far superior to a composite gasket. They seal. They work really good and take a lot of abuse and still work.
The reason why we were talking about the head gasket is because when I said it in the last video that seeing the crack between the valves was a slam dunk, that was the cause of the poor leak down test and coolant getting into the number 3 cylinder, that's not necessarily the case according to Nick and according to guys like Al that have been doing this for a very long time. Those cracks are called detonation cracks, and the crack might not have necessarily reached the coolant jacket, so that crack has to extend into the coolant jacket for the coolant to get into the cylinder. When I said it was a slam dunk, it's not necessarily a slam dunk. It still could be a problem with the head gasket itself and not a cracked head. But we'll learn more once we get the heads out of the cleaner and get them pressure tested. Another bonus for this part of the series is Al is going to show you how to install a valve and how to remove a valve. So we're going to be able to see him do this on a head that they're rebuilding right now.
So normally on a valve adjustment, as you know, you change the valve adjusting shims to adjust the valve. This is a head that's already been run. We're rebuilding it. The seats have been cut, refaced, reformed, true to the valve guide. So instead of changing the shims, we'll run out of shims. We will actually be stubbing the ends of the valves to bring the installed height back into the factory specs.
The seat is right here, correct?
Yes.
And that's a metal seat?
Actually, this is a factory head. That is actually a powdered metal seat.
A powdered metal seat.
What Toyota uses. They take different types of powder and put them together and compress them under high pressure and high heat. And it actually makes a very, very durable seat that work hardens as it runs, which is desirable in valve seats. If you turn around here, he's machining them right now. We have a fixed cutter that we set to the diameter that we want for the seat. We have a pilot that fits the guide very snugly, which will line up with the guide. Unlocks the ball, and that lets that whole thing pivot and lines up perfectly with the guide. And you will start turning and slowly come down and touch it until the seat cleans up. Hear how it started out a little bit uneven, and as you went in farther, it got smoother and sounded more even all the way through. He trued that seat up to the guide, and it's ready to go. It's ready for a new valve now. On these particular heads, we have water ports here, and they will corrode as they run, and the Toyota engine lasts long enough. If you get 200,000 or 300,000 miles on it, that'll be rough enough where a new gasket doesn't want to seal. So we actually put these heads in the mill and resurface this whole surface right here, so it's nice and fresh to hold a brand new gasket.
So is the pitting ever so significant that you have to like fill in the holes or something?
Absolutely. I have a head right now somewhere around here that I have to actually weld it back up. I'll grind the bad part out and I'll weld it back up, and then I'll put it in the mill and remachine it, and it'll be as good as new. Maybe better.
Better than new.
There you go.
Yeah, that one's really pitted, huh?
Oh yeah, it's ugly. What I do is I take a carbide burr and I grind all this out, cut it all out, get down to nice, clean, fresh metal. And then with the TIG welder, I weld it back up, and then I'll machine this flat with the mill, come back in with the carbide burr again and clean up the port. And when I get done, you will not be able to tell anything was done to it.
You're setting out all your feeler gauges, huh?
Yeah, some people use them in the holder. I like to set them out like this.
I do the same thing when I was doing a valve adjustment. Having them free is a lot easier.
I like it. It's a personal preference. I'm trying this. I feel the valve, and this valve is not even touching the seat yet. So I'm going to take a little bit off the end of this. With the machine made for doing that. This is actually a valve grinder. We grind the face off the valve on that end. This end is a stubbing wheel for doing this. And I'll take it out and check it. Okay, I'm going to need a little bit more. This takes a few trips back and forth.
So you're taking a little bit off.
Yeah, I sneak up on it. I do not take off a whole lot at one time. The valve adjustment will change when the head is bolted to the block, and it tends to tighten up. So we leave them a little bit on the loose side so we don't have a problem. A tight valve can burn. A loose valve, at the worst, will make a little noise. Doesn't hurt anything.
And so the way I've explained that to the audience, Al, is that if the valve isn't closing all the way, then when the cylinder fires and the explosion of the air fuel mixture, some of that explosion will blow past the valve because it's not closing all the way, and that's how it burns up. Is that a good explanation?
Absolutely. It's almost like a cutting torch. It's that hot and that much flame. The valves are really good valves, but they can only take so much, and yeah, it will carve a groove into them. Some valves are made where the face is different from the whole valve. Most exhaust valves are stainless steel or some form of stainless steel. There are other variations of that, stellite face for heavy duty application. Those are made to take a lot of abuse.
Hot combustion gases are going past the side of the valve rather than just hitting it on the face. So why is it more prone to burn up in that situation?
It's like a cutting torch.
Okay.
Those gases are like 2,300 degrees or something stupid like that.
Okay.
When the valve is closed, all that's going on, the valve is in contact with the seat. So the heat that's hitting the valve is being transferred to the seat, and from the seat through the aluminum and into the water jacket, and the heat's carried away.
Gotcha.
When the valve is open and there's a gap, the hot gases are blowing through, and the valve head gets hotter and hotter and hotter, and there's no way for it to get rid of that heat. So it'll actually get hot, and then it'll, just like with the cutting torch, start glowing red, and then it'll start blowing pieces of the valve out. That makes sense?
Yeah.
Well, we face the valves,
Yeah.
so we remove material here,
Too. Also.
and that makes this stem go farther up.
Yeah.
And then we machine the seat, and we remove material, makes the stem go farther up. So we have to get back close to what the factory spec is, and that's what I'm doing right now.
Gotcha.
There's two ways of doing that. One way is using the stub height gauge, which I can put on there with it all together, and the valve will come up and I can read that gauge. Some applications I do that on these here with this type of adjustment. The way I'm doing it here is the easiest way to do it. And if I do it right, when I get done, I can put my valve springs on, put it back together, and check it, and all the adjustments will be right.
Steamy.
And that's hot. About 180 degrees now. High pressure hot water.
So they're all nice and clean. It went through the washer. He pressure washed it, blew it out with air to get all the water out. Now we're taking a better look at the heads to see what we can see.
There's a crack trying to start right there. It's not a full crack yet. Right here though, that is a crack. This is a crack. That right there is a crack that's trying to start. Just that little bitty piece right there. This right here is a crack.
That little black spot?
It's not the black spot, it's a line that's going across.
Okay. It's kind of hard to catch on camera, but...
Yes, it is. Well, I've been looking at them for 45 years, so that makes a difference too.
So hard to discern for the average eye. That's why it's good to take it to a specialist, huh?
Absolutely. The experienced guys that work in the machine shop have seen this stuff, and they can spot it a lot easier. There are ways of doing this. They have chemical dyes you can put in that you can spray on and let it soak in and dry, and then you put a developer on. Well, the dye will come out of the crack and it will show it. Of course, on cast iron you can use a magnetic particle tester.
Now this is the cylinder that we determined had the real problem. Even after taking these off, we discovered that there's cracks pretty much everywhere almost.
Well, if you look, you can see this chamber is a different color from these. This color tells me it was getting coolant in it just because of the color. See, this is all coming out shiny, and this here is stained, and when the antifreeze burns, it stains it.
Okay, so it's a staining of the actual aluminum head. Okay.
Yeah. It's not really hurting anything. It's just a surface stain is all it is.
But the head of that piston looked different too.
Yeah. It would. The water does things to it. And there's a crack right here, another crack right there. There might be one starting there, but he's not a crack yet. This chamber, which is the one that had a problem, and there's a good sized crack right there, and a good sized crack right there. One of those cracks might be leaking coolant.
Continuing to that third one, do we see anything in that third one?
You know what? That's a surface crack. Hasn't turned into a full-blown crack yet, but it will. Once they start, they don't stop.
It's pretty surprising to see so many cracks in all these different areas.
That is the one issue with this particular engine, that they do have that happen.
Is this a gross amount of cracks, or is this a normal amount of cracks, or is this...
This is fairly normal for a 5VZ.
And do you have any insight onto typical mileage where you see this type of wear?
I do not see the mileage that's on the engine, so I don't actually know. They don't let me out of the machine shop. I'm stuck here. What we're going to do now, I'm going to take the valves out of that cylinder, and we will look at the cracks a little bit better.
This is the tool that Al's going to use to remove the valves. It's a pretty slick tool, and we'll put a link in the video description for this kit. It's a pretty quick and easy process that Al is going to show us right now.
For taking the valves out, we remove this part. This is the part for putting them back together. On this, there's a magnet in there to catch the keepers. You put it on there and you hit it. I use a rubber mallet so it saves the tool. The magnet holds the keepers. I take the keepers out. Set it on there. Good firm hit. When we first started running into cylinder heads like this with valve rings down in a hole, we had a hard time because we were used to 350 Chevys and 302 Fords. Use a regular valve spring compressor, and then they come up with this newfangled stuff. It was a learning curve. Then Leslie came out with this particular tool, and life got easy again.
So what are these right there?
Those are the valve keepers.
So that's what you're picking out with the screwdriver?
Yes, this is the actual valve keeper right here, that piece right there. And if you want to, I can show you how it works. There's a groove in the valve, and there's a raised spot in the keeper itself. This is a retainer that rides on the spring, holds the spring in place. These keepers fit in that groove, and they're tapered to fit the retainer. The retainer goes on there, and it holds everything in place. There are two different size tools in the kit. You want to find the one that fits inside there. If you use one that's too big, this one barely fits, you hit it and you will make a burr on the side so the lifter will not fit anymore. So be careful which tool you use. All right, this is one of the big cracks right here. And you look down in there, that line, that crack extends underneath that seat, and that line you're seeing there is where the coolant was coming out of the crack.
The crack that we could see between the valves extends down, and this area right here is the seat, and the crack extends below the seat into the port, and he could tell right here that was letting coolant from the coolant jacket get into the cylinder. So we know that this head is done deal, unless you can weld it, but you said you can't weld these, huh?
When they're leaking like that, I do not weld them.
So this cannot be repaired. So we know that the passenger side head is bad because of what we saw, the crack extending into the valve port, and no way we can fix it, so that one is going to go to the recycler. This one on the driver's side, Al said that when they see this many detonation cracks in a head, they don't feel comfortable putting this on a customer's engine, so they're suggesting that Sean scrap this one also. So we're going to be leaving Yota1 today with two remanufactured heads because the passenger one can't be reused, and because of the cracks on this one, we shouldn't reuse this one either. So the general rule of thumb, if you find one head that is bad, you should replace the other one because it's on its way out. As we saw on this driver's side head, he has a lot of detonation cracks. The detonation cracks probably haven't extended into a coolant jacket yet, but they're on their way, and he's on borrowed times. So the smart move is just to put two remanufactured heads on his engine, so he's going to have a lot of trouble-free miles ahead of him.
When we're checking a head that we're not necessarily rebuilding, we want to check the valves to make sure they're sealing. One way of doing that is with a vacuum checking machine, which is what I have here. This is a pneumatic Venturi style vacuum pump. When I pull the trigger, it will let air through. It'll make a vacuum. I will cover the hole in the end with my finger, and you will see the gauge go to the maximum vacuum that this will make. That was 20 inches of vacuum, 20 inches of mercury. This is a closed cell foam that will seal around the port. We'll put that on there. We will be noisy again when we pull this trigger and see how much vacuum this pulls. That went all the way to 20 inches of mercury.
So that's good.
It took a little bit to get up there because this is a low volume pump and there's quite a bit of volume in the port. These valves are sealing very, very good.
Good, okay.
We'll check all of them. Next one. That's the same thing. Next one. That's good. Got different ones with the studs in. This one won't fit.
You got to use a smaller adapter.
So I use a different adapter. That goes to 20 inches of mercury. That one goes to 17. That one goes to 19.
So that one was a little bit lower.
It was a little bit lower, but he's still good.
Still good.
He's close enough, he would work just fine. My rule of thumb, if it goes over 15 inches of mercury, it's good.
So this driver's side head passed the vacuum test?
Yes, just for the valves. If it needed to be used, it would work just fine right now. Eventually it will fail, but it's not quite there yet.
We're gonna next pressure test the head that we know is bad, and we'll be able to see the leak out of the crack in this number 3 cylinder.
What I'm gonna do is I'm gonna finish taking all the valves out of that.
Okay. So to pressure test it, you have to have all the valves removed?
You don't have to, but you can see better with all the valves removed. I do not like pressure checking with the valves in. It's a much better job with all the valves out. That's the way I normally do it. You can see better, so it's more accurate, yes.
It's because you can see below the valve seat, right?
Right.
Okay.
This is an AXE pressure tester, AXE equipment. This particular one, put pressure in the water jacket and submerge the head in the water and look for bubbles.
Okay. I don't think anybody's going to have this at home.
No. Although you can make plates, which I have done before these machines were readily available, actually make plates to bolt onto a head, and with a regulator, put regulated air pressure in the head and then squirt it down with soapy water and look for bubbles. And that does work really good. And you can do that at home. So I put that in place, and then I need to pick out a plate. I do not have 3-cylinder plates, so I will pick out a 4-cylinder plate that will fit there. This is the same plate that I use for the 22Rs. The steel plate has a rubber gasket on it. The rubber gasket will seal all the water jacket holes. One thing about doing this is your visual is a big share of what you do, which, as I'm sure you've figured out, it takes experience to see all that visual just right. But if you take your time, pay attention to what you're looking at, you can figure it out. Now, this head still has the freeze plugs in the end of it, so I don't have to worry about those. Because Toyota made these at an angle, it made things a little bit difficult, so I made special plates for doing this.
So what Al is doing right now, he's blocking off the coolant ports on the head with these special plates that they made and special adapters.
I machined the bolt holes at an angle, and I countersunk them. Then I made a spacer to go in there and hold the bolt head up. Doing this stuff, I'm using the mill and the lathe, and that's just all fun stuff. I have to put air pressure into the water jacket. I do not have a plate that has an air hookup on it to put it in there, so I take a freeze plug out, and then I will use a plate like that. Now this air hose will hook onto there, and that puts air pressure in. Now hit the button, put air pressure, almost 50 pounds in there. Looks like I have a little bit of a leak.
right at Disneyland.
You can see that number 3 cylinder
It
leaking.
is- Yep.
Leaking like a sieve. And that's right where that crack was, extending down past the valve seat.
That one is doing from both sides, from the intake seat and the exhaust seat.
Game over, man. Game over.
If we didn't see that leak right off the get-go, we would turn it and we would look at this side looking for bubbles. We would look for the top. These will crack up here. You don't see very many like that, but it can happen.
No.
Seen heads with holes in exhaust ports that leak. 5VZs generally don't do that, but they can. What I do on these remanufactured heads, because I'm stubbing the valves, I will put the cams and the lifters in and the valves, and I will stub the valves to length. Then I will take it all back apart and install the valve stem seals, oil the guides, put the springs, retainers, keepers on, and put it all back together, and then recheck the valve adjustment. And at that time, if anything is off, I will adjust it by changing the shim like a normal adjustment.
So when you first start off, you do the adjustment by adjusting the length of the valve itself, right?
Right.
And then after you get it all put back together, you're not going to go through the pains of removing the valve again to put it on the machine. You're just going to adjust the valve lash via a different shim, right?
Right.
Okay.
Exactly. That's how I'm going to do it.
Right now, Al has the exhaust camshaft secured in the bench vise. And remember when we were pulling out the exhaust cams, I talked about how there's a main gear and a sub gear, and you have to put the service bolt in so the gears don't become unsprung from each other. Well, Al is now going to show you how you get the main gear and the sub gear back together. So that is the sub gear, the smaller one.
This is a sub gear, that's the main.
The main gear doesn't come off when you take it apart. The main gear stays on, but the sub gear comes off.
Right.
Okay.
Put that spring in. Make sure it's turned so we can see the bolt hole.
It's resting up against the pin, and you can see the bolt hole.
This dowel will go against that side of the spring, so it has to go in the middle. Make sure that's nice and free. Wavy spring washer. Retaining circlip. Make sure it is seated. We'll put dowel in the hole that I made. This can also be done with a spanner wrench. Spanner wrench would fit these two holes and you would turn the gear. The other way, I made a little tool, fits in that hole. I turn that around, pry that over, put the screw in, tight, there you go.
When you're turning that big spring, you're only turning the one tooth?
Yes, just until the bolt hole lines up.
And you're turning it clockwise?
Into the spring, clockwise, looking at it from the top, yeah.
With the sub gear on top of the main gear, you turn it clockwise.
When I'm preparing the cam, I take the galley plug out of the end to make sure and clean the whole galley. If there's goo in there, which a lot of times there is, we can run it through the cleaner again, or we can run a brush through there and clean it and blow out all the holes.
See, these are all oil gallery holes.
Yes.
Oh, nice.
That oils the journal. Also, the split gear has an oil hole to oil the gear. That helps it stay quiet and keeps it from galling as the gear moves.
So for all the heads that you remanufacture, you take the sub gear off the main gear and make sure all this is clean so you know it's getting properly oiled.
Yes.
So now we're at the point where you're going to be putting in valve stem seals?
Time for the valve stem seals.
Okay, time for the valve stem seals. So what are we doing first?
First, I'm going to oil. I'll oil the guide inside and out. Not a lot, just a little bit. I need the inside lubricated for the valve because we don't want the valve to stick. The outside is lubricated so the seal goes on a little bit easier. I use Viton seals. These are a very, very good seal made by US Seal. These are actually better seals than the original equipment seals. Which the original equipment seals are okay. I've used them without issue. Okay, that's the right one.
Alan's going to use an insertion tool for these valve stem seals. How do you know what size tip is the right one?
Well, this is a two-piece. This is the driver for the seal. And I want it to be big enough on the inside so that it clears the lip with the spring. And big enough on the outside so it clears the outside there. but a lip inside that will catch the lip on the seal to drive it into place. This part, the pilot part, is the same size as the valve stem is.
Okay.
And that holds it in place. Goes in there. Slide that on. Carefully tap it on.
Doesn't take much force.
No, it does not.
And when you hear that solid sound, you know you've fully seated it.
Yes. This is one thing I like. These seals have the Viton rubber on the inside, and it seals to the guide. The factory Toyota seals, you don't have to pound them on or hammer them on. They slip right on, and that is what I don't like about it. Once again, on this tool, I use a rubber mallet just kind of to save the tool, and because you don't have to hit it that hard. If you hit it too hard, you can damage the seal.
From what I understand, if you have bad valve stem seals, this could be a situation of why you're consuming oil, correct?
Yes.
So the oil is getting past the valve stem and then getting burnt up into the cylinder, correct?
Yes.
Gotcha. Okay.
Yes. Next step is to put the valves back in, and I have kept these valves in order because they are now custom fit to each position. There we go.
Now next is the valve springs and the keepers.
Valve shims, valve springs, valve keepers.
Okay. So what do we put in on first?
These are the valve spring shims on aluminum heads. This is necessary because the valve spring can actually eat into the aluminum of the head.
And those are all the same thickness?
Yes.
Okay.
They're just a hardened steel shim.
You just drop them in there, okay?
Make sure they settle down into place like they belong. These are the factory shims. Factory makes very, very good shims. Okay, now we need springs and retainers.
So you can see the valve spring shims down in there. Now, is a valve spring something that you would necessarily have to replace? Could you tell if the spring has lost some of its, I don't know, tension? Or is it something that could be reused over and over and over again?
On heads like this, usually they can be used over. We have 4 valves per cylinder. They're small, lightweight valves, so the valve springs themselves do not have to be real massive, super strong valves.
Gotcha.
Therefore, they tend to last a long time.
Okay.
That, and when I set them out, I look at them, make sure they're all the same height. If there is one that is a big difference in height from the other, I can check it. We do have specifications for checking the pressure at certain heights, and if I have any doubt about it, I will do that.
Gotcha.
But on 5VZs, you rarely have to worry about the valve springs.
Gotcha.
But when in doubt, you can always replace them.
Gotcha. Okay. Gotcha.
These are actually pieces I have that we've already cleaned. I have different ways of doing it.
What do you call that?
This is the retainer.
And what do you call those little doohickeys that capture it?
Keepers.
So these are the retainers,
And these are the keepers.
and those little things right there are the keepers. What are those things made out of?
Steel.
Just steel, okay.
They're very hard steel. They're rather brittle because they are very, very hard. The harder a metal is, the more brittle it tends to be. Softer it is, the more pliable it is. With the tool we had earlier, I will put this piece back in it.
So it's that same toolkit that I showed earlier.
The magnet holds this piece in place.
Okay.
We need some way to hold the valves up. I have a freeze plug, a big one. I'll put a dot in the middle so I can see it through the spark plug hole.
So you're putting that underneath the spark plug hole.
Uh-huh.
Okay.
That actually holds the valves up.
Okay.
It's holding the head up a little bit. I take the retainer, put keepers in it, put it on the valve.
So you put the keepers inside the retainer.
Yes.
Okay.
This point goes in the middle of the keepers. Now put that on there and push it down, and it didn't work. What I'm going to do when that don't work is I'm going to start over. Usually that only happens to me like once in a head. This one, it has to start with the very first one. What do you know about that?
Now, are those little keepers directional?
The ridge is towards the top that has to fit into the groove on the valve, and the keeper is tapered. The bottom is thinner than the top.
Gotcha.
So yes, they are directional.
They are directional.
And there you go.
That's properly installed valve spring.
There is one more step we will do after we have them all in. There we go. After the valve springs and retainers are installed, we want to make sure that the keepers are seated. If they're not seated properly, when the engine starts running, the keeper can pop out and the valve will fall down the cylinder and you will have catastrophic engine failure.
I don't like the word catastrophic.
No, it is not good, and it's never a pretty picture. So what we do is take a hammer and lightly tap each one of the valves. And anybody watching real closely, it's hard to see, some of them you will actually see the keeper's seat and the retainer will come up a little bit. Now, I am sure none of these keepers will fall out. If there was one bad enough, it would pop out, but with experience, you can look at them and see it. With inexperience, yeah, if there's one that's definitely not going to work and it pops out, now is the time for that to happen. And you don't want to hit them hard, just a light tap like I did there, and it will seat them just fine, and they'll be beautiful. When I put the shims in the bucket, I put a drop of oil on top of the bucket right here. Put the shim on, oil runs out, makes the outside this a little bit oily. So it's all lubricated. You can oil it more if you wish to. I put the drop of oil in there before I put the shim on. I have some grease, assembly grease. You can use assembly lube. This grease I mix 50-50 with engine oil. One little bit of grease on top. But don't want real heavy grease like chassis grease. That's too heavy and thick.
So you're doing where the bearing caps ride?
Mm-hmm. Yes, I am.
Could you just use engine oil on that?
Yes, you can. Engine oil works just fine, especially if the engine is going to be started in a short period of time, as in like a few days. If the engine is going to sit for, say, a month or two, that's when it's good to have the grease.
Okay, because the grease isn't going to just drip off and go away.
Right. Now, you know these caps on the end has to have sealer when it's put together.
Yeah.
But you're going to be taking these cams back out to put the head bolts in.
Yeah, exactly.
So that's your problem, not mine.
Yeah.
This one here will also have to be done. I don't put sealer on them.
Yeah.
In fact, for Kevin, I don't even grease them. I let him do it. Timing mark is where it belongs. Once again, you're going to be doing this again, so where I put it doesn't matter, but I try to put it right so nobody gets confused. Now this is the tricky part. This has to be pulled down evenly. This is where on a 5VZ engine you can break a cam cap or a camshaft. Either one is real bad. Camshaft, you can get another camshaft. If you break the cam cap, you throw the whole cylinder head away. And we don't want to do that.
Yeah, we don't want to do that.
So what I'm doing is I'm pulling these down evenly by hand and pull them down evenly. But you don't have to pull all of them down evenly. I'm working on the middle one and the rear one, which that's going to be good enough. Now I've got it pulled into place. I use the bolt so I can turn the cams more easily. I'm just feeling it to make sure everything turns good, spread the grease around the lobes. Now I will go back and recheck clearance.
You can't even see the blade. It's kind of hard to see it.
Well, there's not much to see. This is a single point cutter. It has one tool bit on it, which is a round cutting bit made from polycrystal diamond for cutting the aluminum heads. And it spins real fast. Same tooling the factory uses to machine them too.
Gotcha.
Polycrystal diamond does a wonderful job on aluminum. The back is steel. And right there is a little bitty layer that's a little bit darker. That's a polycrystal diamond, which actually the big oil drilling rigs, they use polycrystal diamond on their bits on the drilling head. This little tool bit right here, and this is a small one, this is a more inexpensive one, is probably $200 or $300.
$200 or $300 for that little thing, okay.
Yeah, but it lasts a long time.
Gotcha.
Normally you take somewhere between 5 and 10 thousandths. That's the normal. If a head is warped, then it depends on how much is warped as to how much you take off.
And then obviously there's only so much you could take off before you can't take off anymore and you have to get rid of the head, right?
Right.
What would be the limit of how many thousandths?
That varies from engine to engine. On the 5VZ head, I think Toyota says 10.
10 is the max?
Yeah, you can take off more than that without having an issue.
Okay.
But more than that, then you start running into compression ratio getting too high and the computer can't compensate for it then.
Okay.
And then you run into detonation and nothing good happens after that.
Gotcha.
So, but normally I'm taking off 5 to 10 thousandths, that's it.
That's it, okay. Look at that beautiful machine surface.
You could eat off that.
Yes, you could. It is pretty. I've machined a lot of heads, aluminum and cast iron. When they came out with this technology with the polycrystal diamond, the first time I saw it, I said, wow, this is great. Now I'm putting out a head that looks really, really good. This is a profilometer. It actually measures how rough the cylinder head is or how rough the surface it is on is. Profilometer, and that graph is what is actually reading. This piece actually drags that shaft across the surface.
See all the markers. Okay. There's our result.
There's your RA, your roughness average, 13.25 is very, very fine. It's very, very good.
Factory spec is 50 to 50
I don't
or
know what the
something?
factory is. The Chromatech spec, that's a gasket manufacturer, is 50.
Okay, so
I
this
would
is
not put a
well
multi-layer
below that.
steel head gasket on 50. This is really, really good.
This is the end of part 4. I hope you enjoyed it. We certainly did. I learned a lot. Sean learned a lot. And I know you probably learned a lot. Join us in part 5, where we're going to replace some optional things since the engine is so torn down. Heater hoses, oil cooler hoses, that sort of thing. And then we're also going to prep the block surface for the new head gaskets and the new heads. We'll see you in the next part.